In the previous lecture, we discussed the equation of lines and how to sketch on xy plane. Today we discuss parabola and equation of parabolas and how to draw them on xy plane. Here you can see that I just write one equation of parabola. Basically there are four equations of parabolas. From them I just write one equation. Right now I just discuss one equation. One equation is y square equals to 4ax. Parabola, basically the equation of parabolas involves two variables y and x. One variable with power 2 and other with 1, other with 1 power. You can see that right here y has degree or power 2 and x has degree or power 1. I just told you the direct method to sketch on xy plane. Now direct method. What do you mean by that? The direct method, I can told you that so many students were confused how to draw a parabolic equation or parabolic graph by looking at the equation. Now I'm just told you that two variables involved with the power 2 and with the power 1, and 4ax is constant. 4a is constant. It comes in equation or not come in equation doesn't matter, but the two variables matters. Now I'm going to sketch the graph. You can see that, always see that the variable with power 1, the graph actually plot along that axis, and you can note the sign of that equation, whether this sign is positive or negative. Therefore the graph it becomes like this, along positive x-axis, because here sign is positive and the degree of x is 1. As I told you that the variables with power 1, the graph actually draw along that axis. Now I just write another equation of parabola. It is the same equation as the above one, but with a negative sign, but with an additional negative sign. How to sketch this? This is the same way to sketch this on xy plane, but as I said that the parabola, the graph is sketched along that axis whose power is 1, along that variable whose power is 1, and you must notice the sign whether it is positive or negative. In this equation it is a negative sign, so parabola will be drawn on negative xy plane. Now I just write the third equation. Here you can see that on the above two equations y square is come on the right side and left side, and here x is come on the left side. So the same method will be followed, that using how to draw. As I said that graph is drawn along that axis whose power, the variable whose power is 1, and you must check whether the sign is positive or negative. Here positive sign is positive, so the graph is sketched along positive y-axis. Positive y-axis. I just drawn the equation number 4 graph right here. As you can see that the equation number 4 is just opposite to the equation number 3. What is the difference between equation number 3 and equation number 4 is basically here is a positive sign and there is a negative sign. Same scenario will be happen, but the shape of above drawn parabola is inverted like this one. Now the graph of parabola will be drawn along negative y-axis. As I told you that parabolic equation may be written as y equals to x or x square equals to y. You are curious that where 4a is gone. In this equation, the general form of the above equation is y square equals to 4ax, but I write y square equals to x. Now carefully notice that y square equals to 4 is a constant number, so it doesn't change, while a is a constant and a has any value whether it is a negative or positive. Now here a has a value 1 by 4 into x. So our equation will become y square equals to x. So I just told you that it doesn't matter that it is a general form of parabola, and usually in the questions the form will be given as like y square equals to x, or x square equals to y, or x square equals to minus y, or y square equals to minus x. So just don't get confused. After discussing equation of lines and parabolic equations, now we finally discuss an example of piecewise defined functions. As in the lecture number 1, I told you that piecewise defined function are those functions which can be written in more than one expressions. As you can see that there are 3 expressions involved. In piecewise defined functions, you just have to draw. Okay? Draw them. You just have to draw each expression on xy plane. Now I just told you that how you just draw on xy plane. I just take number 1 expression, which is 2x equals to f of x equals to 2x plus 3, or y equals to 2x plus 3. It is a linear equation. In lecture number 1, I just told you about x-intercept and y-intercept. Now here we use the same concept about x-intercept and y-intercept. X-intercept. For x-intercept, put y equals to 0. Therefore, 0 equals to 2x plus 3. Therefore, value of x equals to minus 3 by 2, or in decimal form value of x will become minus 1.5. Now we just get the value of x using x-intercept. Now we are interested in finding the value of y, therefore we are using y-intercept. For y-intercept, put x equals to 0. So put x equals to 0 in this equation, then the value of y will become 0 plus 3, then value of y will become 3. Now I'm going to draw this equation on xy plane. As you can see that I can just draw my xy plane, and we get the value of x, that is minus 1.5. So 1 is this, then 1.5 is little bit away from 1, so like this, and y equals to 3, then y equals to 3. As you know that the graph of linear function is always a straight line, therefore it will be like this. This graph starts from 3 and goes down infinitely, then this end is not ending at any point, while this point ends on 3 because y equals to 3. Okay. Now I just write the second expression, which is x square. F of x equals to x square, or y equals to x square. This is a parabolic equation, but you have to parabola along positive y-axis like this. The graph of this equation x square equals to y will be like this, but you have to keep in mind the condition if 0 is less or equals to x and x is less than 2. This is a condition. This is the condition of this equation. So keep in mind that. Now I'm just going to draw using this condition. Now I just told you that this is an equation the graph of this equation is along positive y-axis, but you have to consider this condition. This condition actually limit our graph like this, that x always greater or equals to 0 but less than 2, not equals to 2 but less than 2. So the graph will become like this. Now our graph will become like this. You can see that there is an open hole. Open hole means that it is a discontinuous function at that particular point. So at 2, when y equals to 4, how do you get y equals to 4? Now you can see that in this condition, if you put 0, then y equals to 0. You can see that here y0, x0 and y equals to 0. When you put x equals to 1, y equals to x equals to 1, then y equals to 1, then you can see that here x equals to 1 and y equals to 1. If you put x equals to 2, x equals to 2, then y equals to 2 square, then y equals to 4. Then actually we got value from putting x equals to 2, then y equals to 4. Like that it will goes like, when y equals to 4, x equals to 2, then y equals to 4, and at that point the function is discontinuous, so I put hole in there. Now I just take the third expression, which is f of x equals to 1 or y equals to 1. So basically this is an equation of y-axis. Equation of y-axis, because in this equation x is 0. X is 0. Therefore, I just draw this equation on like this. This is positive y, negative y, x, negative y and positive x. As y equals to 1, and condition will be x is greater or equals to 2, y equals to 1, but x initially starts from 2. Therefore, our graphs will be started from when x equals to 2 and y equals to 1 like this. Because this is an equation of y-axis, as I told you, x-axis will be same and x-axis will be changes continuously. Now I just plot the graph of expression number 1, this and this on a same plane like this. First is, you can see that I can just like this. Second is in a parabola, but here is a limit that when x is 2, then y equals to 4 like this. At 2, graph is discontinuous. And the last one will be that y equals to 1 when x is greater or equals to 2. Our x is started from 2 and y equals to 1, so the graph of this equation will be like this. So this is the complete graph of piecewise defined functions. So take a minute.